Okay, so let's get started. Exploratory online seminar number 43, cohort analysis part 2. This is a survival curve, but what we want to do is focus on the retention and the churn. Those are the two most important things for any SaaS, software as a service, or subscription business. Okay, so we have these three topics. Let's get started. So let's say, I think this is part one. We look at the, I talked about the MRR, net retention revenue types of things. So same chart, we are basically looking at like MRR for each month, and it looks like MRR is growing. But last week, what we were talking about was like, hey, not just looking at the MRR, but it's actually important to divide the MRR by the cohort of when the users converted or when the users become the paid customers. And then you can see how efficient that your business is growing or can grow further. Right, so this each color is basically like when the customer signed up or converted. So like such as like 9 months ago, 8 months ago, and so on. And then because we are looking at sort of like on the over time period, so like we change that chart type to area chart so that you can see the sort of like gradual difference of maybe like expanding or shrinking of each cohort in terms of the retention revenue. Okay, and then ideally, you want to see that each cohort expand the retention revenue or net retention revenue. Then that means your business is actually growing very efficiently. That means you don't have to spend a lot of money for acquiring new customers because your existing customers are actually expanding, which is a good thing, and so on. So that's what we saw with a layer cake chart, like we saw in the previous slide, previous page. So now the net revenue retention, basically that's what we are looking at, right? So, but that is, when you think about it, is a result of customer retention and churn. The customer retention and churn, those are like opposite side of the event, opposite side of like same basically event. But if you want to see how your customers are churning, I mean, not the result, but like let's say like you care about how the customers are retaining or churning, or if your customer retention is getting better or not, then you want to see the retention rates over time and compare them among various cohorts, such as when the customers converted. Okay, so let's say the example question you might have in any subscription business is that over the customer lifetime, when do the customers churn the most? Or maybe, for example, like at the first month, they churned a lot, or in the first few months, maybe like first, second, third month or so on. Or it doesn't have to be months, it can be week, can be year. So we want to see like where the retention drops the most. Or does the churn stabilize after a certain time period? Maybe like our first couple of months, like, users are not sure, but after that, the retained customers tend to appreciate the value that you provide, so they might stick around for a long time. Or maybe the retention rates keep dropping down until everybody disappeared, everybody quit. So that's the kind of thing that you might want to know. And then, if the retention becomes stable, when does that get stable? And then once it's sort of like a stable phase, then what is the retention rate at that point? Because then like you can kind of expect how many customers actually retain, then you can sort of like start building your revenue projection and so on. So typically, like what we do is we calculate the retention rates through the customer lifetime, and then draw a curve like below. So this chart, and then like let's say the x-axis is a month, so like the first month, the second month, and third month for the customers. And then maybe, of course, like you start with 100% customers, right? Like nobody churn when they just converted. And then the end of the first month, maybe like 60% of the customer retain, but 40% of the customer churn, and so on. And in this case, for example, look at the second month, it says 48%. So that means 48% of customers retain through the second month. So these are the customers retain, didn't churn the first month and then didn't churn the second month. And by visualizing this way, then we can see where the retention rate drops more significantly than other periods. In this case, obviously the first month, we see the drop is more, like much higher than the other periods. So we might say, hey, something going on with sort of like first month experience. And typically like this is sort of like expected, like many folks want to try a little bit, and then quickly they decide this is not for them, and then so they disappear or quit. That's sort of expected, but the question is, does that get stabilized over time? But nonetheless, so in the this is in the statistics world or the data science world, we call this survival curve, and each retention rate that we just connected to draw this line is called survival rate. So throughout this seminar, like I'm going to use this word survival curve, survival rate, just to kind of get to the basic of this, what this algorithm or what this method is. So how to calculate the survival rates or retention rate over time? So let's think about some like a business case, like example. So let's imagine like any type of subscription business is fine. By the way, like we as Exploratory, our business model is a subscription model as well. So you pay, every month if you are paid customers, and then you pay every month or every year and so on. So let's imagine like we have 4 customers, and then they started using from January. And then the second from the top called Tiang cancel in March, right? And then the last person, the Victor at the bottom, cancel in February. But the Jessica, Nancy, they've been using through the April. Okay, and then we don't really care. Like when we care talk about this like a survival analysis thing, we don't really care like a first like January or August, or July, that kind of stuff. It's what we care is like how long has it passed since they started using or they converted. So we change that unit to first month, second month, third month, and 4 months, and so on, instead of January, February, March. Okay, and then we can calculate. We can calculate the survival rate, or you can say like retention rate of each month, right? And the first month is easy. It's like everybody retain. So of course it's like a one. One means 100%. The second month is we had 4 customers, and 1 person, Victor, churn. So 3 divided by 4, which is 0.75 or 75%. And then the next phase is the third month, becomes 0.66 or 66%. That's like retention. So what we are looking at here is 1, 0.75, 0.66, and 1. Those are the survival rate of each month. But what we actually wanted to know is what is the survival rate or retention rate through that period, until that period, right? So in order to calculate the numbers, we can actually just multiply, right? So for example, what is the survival rate through the second month? Then we can calculate 1 multiplied by 0.75, which equals 0.75. So that 0.75 or 75% is the rate, survival rate through the second month. So that means, okay, for our customers to survive through end of the second or like first month, it's going to be the survival rate is going to be like 75%. 75% of the customers will survive through that period. The same thing for the next month. So this is like a third period, like a first, second, third month. We multiply. So the up to the previous month, the second month, which is a 0.75, that's a survival rate. And then the third month, in order for them to survive on the third month, is 0.66. So therefore, we multiply 0.75 by 0.66. That becomes 0.5. So that's the 0.5 or 50% is the survival rate for the customers to survive through the end of 3 months. And the same thing for the last period. And then so now the survival rate through the period becomes 1, 0.75, and 0.5, and 0.5. Right. So this number tend to keep going down. So if you're talking about the survival rate of each month, then that number can go up and down, or any combinations. But survival rate through the period is always kind of keep going down because you're multiplying the survival rate of each period. Okay. But in reality, though, the customers convert at different times. So you never have all the customers converted on the particular month, and then never have any customers convert later, right? So let's say the same number of the customers. It's like actually there's one person added, but we have 5 customers, and then each customer converted at the different timings. Okay. Again, we don't really care that if they converted January or March or May in this survival analysis, or in terms of survival rates. What we care is how many months they are in. Okay, so we change that. So like I basically, original chart, and I move all of them to the left side, and then change the unit to first month, second month, third month, and 4 months. Okay. And then we can calculate the survival rate through that period, right? So in order to do what we have to calculate the survival rate of each month. Here's a problem. Look at the Nancy, which is the middle. We don't know what happened to Nancy at the 4th month for her, because the 4th month for Nancy is actually the future at this point. Because here, Nancy's converted February, and let's pretend like today's April, right? And then we don't know what's going to happen to her in the next month. So it's a question mark. The same thing for Jane. Jane just converted recently, so we don't know the second month, third month, 4 months, how she's going to be surviving, she's going to be retaining or churn. We don't know. So then how are we going to calculate our survival rate of each month? Well, we label them as something called sensor. This is a kind of special term in the survival analysis. But what it is like we pretend like they don't exist in this particular period. So for us to calculate the survival rate, we just ignore them. So the survival rate for the second month, I think this is the second month. Yeah, second month, now we have 0.75. What that is, we calculated by 3, having 3 divided by 4, not 5, because we don't know the Jane is there or not. And then the same thing for the 4th month, we pretend like Nancy doesn't exist from the beginning, so we don't even add that to the calculation. So it becomes there's only Jessica, and then Jessica still retain in the 4th month, so the survival rate is 1. And once we get the survival rate of each month, then we do the same thing to calculate the survival rate through that period. Okay, it's actually kind of I don't think I'm saying anything special. It's pretty common sense when you look at this, but this idea of sensor is actually important in this survival analysis to calculate the survival rate. However, you're not gonna calculate this by using the pencil and the paper kind of stuff. So you never really have to care about it. But if you might see these kind of numbers in once you start working on it. But you don't even, if you get confused about this sensor, like you don't really have to worry about that now, or you can forget about that now for now. Okay, and then once we get the survival rate through, then 1, 0 0.7, 0 0.5, 0 0.5 thing, then we just connect the dots, and then we get the survival curve. Okay, so that's a survival curve. And then there is an algorithm called Kaplan-Meier. You might have heard about it. You tend to hear this thing in more like epidemiology. I mean, speaking of coronavirus. The whole epidemiology world, they use this type of analysis method and then use this Kaplan-Meier estimator to calculate the survival curves or survival rates through the lifetime, taking into the account for the sensor data. And this is why, like I was saying, like, hey, you don't have to worry about the sensor data because when you use this method or algorithms, then it takes care of it when it calculate. And this is sort of like why it gets kind of complicated if you try to calculate by yourself by, for example, summarizing or aggregating kind of stuff. So it gets a little complicated. So that's why we have this useful algorithm. And in Exploratory, you don't see that word called Kaplan-Meier. Instead, what you see is a survival curve. And then that actually does the same thing that Kaplan-Meier estimator is doing. Okay, and then let's try it. I'm going to show you a quick demo how to do it. But before doing so, this algorithm or this method requires the data in a certain way to be prepared. So each row represents one observation. And each observation needs to have the following information, like start time, end time, and event status, which should indicate if a given observation has canceled or quit or died or disappeared or that kind of stuff. So what that means is here's the data, right? So now observation meaning it's really what you're interested in. Let's say like in this context, we're interested in customer. So each customer is each observation. So therefore, we need a column to identify the unique observation. So typically user ID or customer ID or something like that. And then the first day and last day, we need these two columns so that the algorithms or analytics knows what's the survival period of a given customer in this case. And then the most right-hand side says event status. In this case, I mean, like a SaaS or subscription business, typically this is the cancel. And it has to be logical. That so indicates, if it's true, indicates the customer churn or not. So we're going to use this sample data. However, if you're lucky, you have your data to be in this format, right? That's pretty great. But you might not have the data to be this way. And that requires a little bit of data wrangling. You have to, for example, like let's say that you have a payment information, then each row is not representing each just customer, it's actually representing each customer's payment of a given date. Then you have to aggregate to make sure that each row represents each customer. And then you got to get the first payment day and the last payment day, and then you might not have the cancel column. That information might have, might be somewhere else. That you might have to join the two data frames together to get this data. And that is something that like I'm preparing for, like how to do the data wrangling to prepare that data like this. So it should be published probably today or tomorrow or some. So in that case, just stay tuned for that. And so now for this seminar, I'm going to use a published data at the Exploratory data catalog. Okay, so let's go into the Exploratory here. Okay, so click on the data frames next, and then there's a data catalog. And that data catalog is where you can publish the data if you want to publish privately or publicly or privately. And we have been sharing many data here so that you guys can use it. And so I'm going to just search by the cohort. And then there are two data. The one is a layer cake data for the layer cake that we used last seminar. Today, we're going to use this one, sample data for cohort analysis survival curve. You can click on this open button to see the detail at our website, but I'm going to just click on this import button to import that data. And then I'm going to click on save. And I'm going to change, this is a kind of like a long name. So I'm going to change the cohort analysis survival curve. That's cool. and then just imported the data now. So, okay, so when I go to the table view, I have the user ID. We can check, for example, user ID, we have like 3,390, that's a unique value. And then when you look at the number of the rows, that matches. So that means we are sure that each row represents each user. And there's no duplicated user ID here. Okay, and then like we have the first day and last day, and then luckily we have the cancel. That's like an event status column. So we can go ahead start creating a survival curve. I'm gonna hide the left-hand side, and then select the survival curve, which you can find in the middle. And then I'm gonna assign start date and then end date or last date. And then I'm gonna select the canceled column as an event status. That's it. Then you can click on this run button, and then you get your first survival curve being generated. And then now, what is this x-axis? So y-axis is survival rate of each period, or I mean, survival rate through the given period. But what is the x-axis? It says period. And that is here, is the period is currently set to week. So, and you can adjust it. So what we are seeing here is, for example, here, survival rate 72%. That means that by the end of first week, 72% of the customers retain, but almost like a 30% churn. And if you want to change this sort of like a unit or the aggregation unit to, let's say, months, you can change it like under the period by, like I'm going to change it to months. Then we can see the survival rate through a given month. For example, up until like end of the first month or until the second end of the second month and so on. Okay, so we get this here. That's our first survival rate. Here you go. All right. So this one says survival rate is 67%. That means about 30% of the customer will have churned by the end of the first month, and that's some. And then like after that period, so like that's kind of like a steep curve at the first month by the end of the first month. But after that, the curve kind of settle, so it's not as steep as before. And it seems like sort of like a churn seems to settle after the period. So by just drawing this survival curve, you can see like the sort of the pattern of your customers' churn or retention. Okay, and then you can go to the data tab, and then you have a bunch of columns. And the first time you might get confused, and what are these? And then I have prepared some prepared a slide, and also the series of slides that explain what the observations, events, sensor, the survival rate, what are those things with these charts. I'm not going to go through in this seminar. So if you're interested in, I'm going to publish this this slide later, and you might want to take a look. You don't really have to know at this point, so that's why like I'm skipping, but some folks might be interested in. Okay, so we got this survival rate, our survival curve, but is this retention rate trend up? Is this a problem? Is this good or bad? What should I take? I mean, like now we know like how much of the customers retain or churn and in any given period, but what does this mean? Well, this is Winston Churchill's quote. It has been said that democracy is the worst form of government, except all the others that have been tried. So, when you have one thing, and it's easy to sort of like, think this is good or this is bad. But until like you compare with others, we as a human being, it's not really, we can't really say this is bad or good, right? So like you wanna compare basically with others, then finally like we can say this is good or bad, or so on. And that's where the cohort analysis comes in. So the cohort analysis is really basically you basically draw the survival curve for various groups, and you compare them, and then evaluate which is better or how bad, that kind of stuff. So But this cohort, the word cohorts, kind of like used to scares me because it sounds like kind of special word. Well, it turned out it's just a group or maybe like segment, right? So nothing special about it actually. But it came from this type of analysis came from like the medical world or epidemiology. So that's why they use a special word. But it's really the group. And each group is called cohort, and then we observe or we basically visualize, in this case, a survival curve for each cohort. So let's say like we have the mobile users and PC users, or customers who are using mobile to access your service, and then using the PC to access your service or something. And then we can draw the survival curve for each, and then we can compare. And in this case, for example, this is kind of like obvious. The mobile users' survival curve is very moderate compared to PC users. And that means the mobile users' survival rate is better, and therefore retention rates are better. So we can say like, hey, something going on with mobile users. Probably like, the mobile experience is much better, or maybe some of the value that only mobile users can get out of it. Something's working. But however, something's not working for PC users. So when you see, have two and they compare, and then when you see something like this, and that's where you want to pay attention to why the PC users experience, why churn or the survival rate is not great for the PC users. Okay, so this cohort analysis also, we can do that quickly in Exploratory. So let's say like we want to investigate if there's any difference between the Mac users or Mac customers and Windows customers in terms of the survival rate, right? Survival curve. Okay, so let's to do it's pretty simple. You can use this color by, and that creates the cohort or multiple groups. So just like you create a line chart. So I'm going to select this OS columns and then run it. And I got two lines. Like a blue is for Mac and orange is for Windows. So it looks like, just by looking at this, the Mac cohort is better than the Windows. So something going on, maybe Windows, maybe there are special bugs for the Windows, or maybe experience is better for the Mac. I don't know. So okay, so the Mac is better, but is it really like you? I just said like Mac is better and Windows bad, and okay, you know what? Like let's look at Windows. Let's interview Windows users, or maybe start testing like Windows version of the Exploratory and so on. But is that really like should we really do it? The reason I'm asking this question is let's take a look at the difference at the first month, right? So there's a difference. Mac is better and Windows is worse, right? The survival rate for Mac is better. But let's imagine like you had only 10 customers, right? And then out of 10 customers, 3 customers churned by the end of the first month. Then the survival rate through the end of the first month is 70%, right? 70%, only 70% the customers retain, in another word. So that's what this 70% mean. But if one of those 3 churned customers actually somehow he was or she was indecisive, and in the previous scenario she churned, but in this scenario, let's just imagine like in the last minute she decided to actually, I'm going to try another month or something. Then that will change the survival rate to be 80%, because 8 people ended up like retain, right? So like 80% out of 10 people. So that makes the survival curve to be the first month is 80%. And the rest of the period, I just kind of randomly kind of connect the line, but focus on the first month. The first month is 80%. So the original Mac blue line becomes even higher, so even much even better, right? But opposite thing can happen too. So the original scenario, the 3 out of 10 um, churn and 7 retain. That's why we said 70% retention rate. However, if that's out of those 7 retain in the previous slide, what if like one person decided to churn? That person was also indecisive, and in the last minute something happened, like decided to go away, quit. That will make the survival rate to be 60%. And if this is 60%, the survival curve goes down significantly. And then now at this point, looks like the Mac survival curve is actually worse than the Windows. So we thought Mac was better, but now the Mac is worse than the Windows, just because of that one indecisive person, right? So that was just a kind of simple example, but that kind of thing that we want to actually consider, because if we decide, let's say like Mac is better, Windows worse, and then like we're going to start investigating why is that, and it's going to take some cost and the time, right, resources. So before we do that, we want to make sure, like when we say Mac is better, we want to make sure we're really sure that Mac is better, not by the chance that Mac happened to be better in this particular case, right? So that's what I'm trying to explain here. So just a few customers' churn can influence the survival rates a lot. And especially when the number of the customers is kind of like a small amount. Right. And then like we don't know, like if comparing the among those two, between those two, it's not really reliable. But if we had 100 customers instead of 10, so like something like this, right? So beginning of first month, we had 100 customers, and at the end of the first month, we had only 70%, 70 people retain. So then the 70% is the survival rate here, right? And then that person, you remember that person who was indecisive, and but the last minute decided to not churn. Let's give another chance for the next month, right? Then that will make the impact on the survival rate. But that impact is only like 1%. So now like we have a 71% survival rate. And if we change to 71%, compared to original max survival curve, it's not much of the difference at that first month period, right? An opposite scenario, let's say you remember the person who decided to churn at the very last minute. It's just, he changed his mind, and then now we have to change the survival rate. But that difference is only 1%, so, and now like we have 69%. And then this is like now light blue color, the 69%. So for in this case, if the one person either like deciding to churn or not churn or retain, make the difference, but the difference is very sort of like small. And either way, we can still say like, hey, Mac is better than the Windows. So what we are seeing here is the survival rates vary. So, there's a variation. Whether a few customers churn or not can make the survival rates different. In the example, I use just one person, but maybe few people might behave like that. The difference is depending on how many customers we have, right? So the more customers, let's say like we have 1,000 customers or we have only 10 customers, it makes a huge difference in terms of like how much variation we're going to get. So in that case, we can't simply conclude that they are different just because a given pair of the survival curves, in this case Mac and Windows, are different. So how can we compare the two and conclude if there is a meaningful difference or not? In this case, meaningful difference, it's enough difference that we should take some actions. So that's where the confidence interval comes in. So we want to show the range for the survival curve so that we can say that the true survival curve will reside within this range. Then we can compare the two survival curves with such ranges, and then see if one is really better than the other. So there's some kind of like get into the little statistics world. So but we're talking about survival curve, but we typically this kind of confidence interval, like we talk about, mention this, we use this in the context of like a mean or ratio, means average. And then typically say, hey, this is like, let's say like you do the survey and then ask customers to, evaluate this seminar is good or bad from 1 to 5. And then many people, score the different things. And then this particular, seminar, we get 3.6. But we don't know, like, again, the same thing. So that's a true score. Happen to be, we have the 5 people or 10 people or 100 people, probably is different. And, maybe like the same seminar doing with different people, and you might get a different score. So in this case, what we do typically in the statistics world, we draw this like a 95% confidence interval. That doesn't have to be 95%. It can be 90%, can be 99%. It just happened to be 95% is the sort of like common or pretty standard. But what this 95% confidence interval really means, in statistics world, or more like theoretically, then when you have something called population, it's like your target customers, entire target customers. And if you have customers in your hand or like in your data that happen to be just, sort of randomly selected from the entire population, then like you imagine like you do that sort of like the sampling from the entire population, entire like your sort of a target potential customers, and then you collect like 100 customers and do repeat that process, and then you apply some kind of formula to calculate the 95% confidence interval, right, for each group. First, of course, like you have to calculate the average or mean, and then you draw the 95% confidence interval. And then if you do it, then if you do like 100 times, for example, then out of 100, 95% of those, including 95% confidence interval of those 95 samples should include the true mean, like a true mean meaning it's like mean of the entire population. That means 5 of them might not include, but we can say like 95% of them should include the true mean. What I mean is like, let's say like if you get like, sample like 100 times and literally like you calculate the mean and then calculate the 95% of confidence interval, and then 95 of them should include the true mean. In this chart, the center blue line is a true mean. Okay, so what that means is like we have this formula. I was just trying to explain what this formula, 95% confidence interval calculation, is really trying to do, and we happen to be looking at one of them. We can do the same thing for the survival rates. In this stuff, like if you get kind of still confused, I'm sure you might be. I'm not sure. Like I have explained it really well. So I have done the seminar in the past called "Visualizing Uncertainty" by using the error bar. So you might want to take a look at it. You can go to our search insights and then type confidence or error bar or something like that. Then you will get access to that seminar. Okay, let's go back to exploratory side of things. So there is a checkbox to show confidence interval, and then not just the line, but also you see the range. And the key thing here is if those ranges or the confidence intervals are overlapping each other, then that means, like the way to think about it is that let's focus on the mark, and then the center, there's a line, and then range is kind of like the area. And then that means the real survival rate or true survival rate can be different, but should reside in this range, right? At the 95% of the chance. So that means if those two ranges are not overlapping, that means we can conclude that there's a significant difference between the two. So the mark and windows up to like the period 3 or 3 months looks like there is actually a difference. But after that, those two kind of like lines overlapping each other or the area overlapping each other. That means after the 3 months, the mark and windows becomes most likely, more or less the same. So we shouldn't be really spending our effort and resources for investigating that period, but maybe we should look into like, what's going on in the first month and second month and so on. Okay. And then, okay. And then how about the difference among the countries? I have this, let's look at the another one. So now like we are seeing the OS and I just click on the confidence interval and we are basically comparing these two. And as long as they're not overlapping, there's some significant difference. If you are familiar with the statistics, and then you can actually go to the summary view and see this like something called log rank test, and you can see the p-value as well. Okay. If you're not familiar with it, and don't worry about it, that's not really the big problem here. Basically, like what we want to see is there's a difference between the two and which is better, right? Okay, so now we can change the color to country, but let's say like I'm going to change to country. And then if I change it, immediately you can see like other group frequently 50 bracket 87. What this means, there are 87 countries data in this data. 87 countries in this data. And if I click without having this setting, then you're going to see 87 lines. And therefore, this green thing is basically, hey, you know what? Like you want to, let's keep the most frequent 50 countries as they are. And then put the rest, in this case, the 37 countries, put them together in a group called other group. Then we're going to end up having 51 groups. Then you're going to have like 51 lines. But hey, I mean, 51 lines is just too much, right? So, so what I can do is I'm going to click on this green and I'm going to change to like a 3 and then click on apply button. And what this is going to do is keep most top 3 frequent value. What that means, if I go to the summary and take a look at the here, the United States, Japan, United Kingdom, and 1,005, 1,152, like this is customers or users, right? So I keep those 3 as they are, and then I put like India, Brazil, Germany, and all the other countries in the same group called other. And then like I basically draw the survival curve for those 4 groups. And that's what we are seeing here. And then if I change the confidence interval off, and then I can see like United Kingdom is at the top, and then looks like Japan is the next, and then United States, and then all the others. And if I put the confidence interval and whoa, like this is like overlapping. So maybe like there's no difference and like what's going on here. So this is a kind of be careful. So, but it depends which country you're comparing. For example, let's say like I'm gonna disable Japan, the United States, and then just the United Kingdom and the others. And when you compare the others, the United Kingdom's survival rate, even though the range is bigger, that's because United Kingdom's data is less. Is we have only 253 customers compared to United States and Japan. It's so the bigger the sample size, the bigger the customers in this case, the shorter the confidence interval area gets. So that's what we are seeing. But when you look at the United Kingdom, the others seems like up to the second period or even like third period, there seems to be a significant difference. So we can conclude United Kingdom survival is pretty good compared to others. But when you compare with, for example, United States and the United Kingdom, and it seems like there's a lot of overlap, especially after the third period. I mean, first, second, there's overlapping, but it's slightly, so there might be some difference. So, and I think that's something like you can look at it. Okay. So now the last thing, actually, we are basically separating by the OS and the country. One more thing we want to look at here at the last. So one of the things we wanted to originally know is whether the customer retention is getting better or worse over time, right? We basically observe the retention rate or retention is worse or better between the two OS or among the various countries, but we want to see if it's getting better or not over time. So what that means is like the recent customers tend to churn more or less compared to the old customers. That's what we want to see. Then to do it, like we can create the cohorts not based on the which OS or which countries they're coming from, instead based on when the customers converted. And then draw the survival curves like this. And each line is a survival curve for the group of customers, based on when they converted. For example, the blue line is like the customers converted in January, and so on. Okay, so the most right-hand side is actually Japanese, but it's actually 1, 2, 3, 4, 5. That means January, February, and March, and so on. And then in SARS, business, especially SARS, like you hear the cohort analysis a lot. And generally, people means actually this. Like it's not really the OS, but it's really when they converted. That's the cohort that we usually talk about. By looking at this type of chart, what's cool about this is that if the survival curve, in this case, this color, I don't even know what the color is. It's kind of a greenish, brownish, whatever the color at the top. So that is the cohort of the people, customers who converted in the very recent months. And they compare to older cohorts, the survival curve is getting better. The higher is better. So that means that we can say the recent customers' survival curve is getting better. That is a good sign of our service or product is improving from the customer point of view. On the other hand, if that's the order is opposite, so that means, the recent customer survival curve is worse than the older customers cohort survival curves, then that's an indication of like your service is actually getting worse, or somehow you have the customers, you're acquiring the wrong kind of customers, or something's going on, and this is a bad sign, right? So that this type of the chart actually helps, like where you should look at how to, which area you should pay more attention to. So we can do it in Exploratory. The one thing though, seems kind of easy, but there's one tricky thing. So what we want to do is here, because you remember the first day is basically the converted day, right? We can consider as a converted day. However, we can't select the first day because that column has already been used for the start time. So that's why it's grayed out. But of course, you can work around this. So you can copy this column and then save it as a different name, right? So that's what I'm going to do. I'm going to select the create calculation for the from the first date column header menu, and I don't have to do anything, just a column name here. And then if I click run button, this will basically return the first date value for each row. And I'm going to name this as a join date or something like that, just a different name, or converted date, whatever, that's fine. It's basically the copy of the first date. Now I have this join column hasn't been used, right? And I'm going to go to the analytics and I want to assign that join column. Then the join date is not there because the pin button right hand side is still pinned to the step before I created this join date column. So I'm going to move this pin to the second step. And this way, now I can see that join date column in the dropdown. Then I'm going to select it. And I can click run button, but if I click on it, look at here, this is like a year. So that means I have probably like only 1 year with the customer. So like you're gonna see like just one cohort. What I want to do is I want to create a cohort based on which month they converted or they started using. Then I'm gonna change the month and then click run button. Then I get multiple. And I'm going to just disable the confidence interval. It's kind of too much here. And then now I see like 2016 May 1st. These are so blue. These are the customers who converted 2016 May. And opposed to here, for example, this line. I'm going to double click here. This line is the customers who converted 2017 January. Any day in January. Okay, I'm going to double click here. And then what we can say is, for example, like what we want to observe, is it getting better or getting worse, right? So the oldest cohort is this one. And the next one is the orange. This is like a 2016 June. So it's actually getting worse. And the next one, 2016 July, it's getting worse. And whereas the next one, like August is red, it's getting worse. So it seems like it's survival curve is getting worse, that means something's going on. Maybe something's not clicking. Maybe like the first month or second month, the drop is kind of significant. So maybe like we're not, supporting the customers, getting into the exploratory or whatever the service we provide. But when you pay more attention here, though, like the purple is September, and then what's next is here. This is October, and October actually got better, a lot better. And the next one is November. November got better too. So it seems like it was kind of going sort of like a worse, but once hit the rock bottom, probably this is like August was the worst time, and then seems started bouncing back. So I don't know, like somebody did something to improve our product. Maybe we release newer versions or something's working. But this is kind of like a fictional thing, but that's the kind of trend that you want to actually track as well. And then when you say cohort analysis, typically you see this kind of heat map way. And basically, this is like just a different format of looking at the same data. Survival curve, you see these numbers connected as a line. Survival table, you see those numbers in the metrics or the pivot table way. I prefer survival curve, the line, because you can see the trend much more intuitively. And then this is the one we actually use for exploratory as well. Okay, so that's that. And then, if you like, though, for example, you can use a repeat by. And then we can say, for example, between the operating system, and if there's any difference, for example, Windows and Mac, let's say left-hand side is Mac customers and the right-hand side is Windows customer. It can be PC and then mobile or any segment, maybe like financial industry and the pharmaceutical industry, any group. And you can see like, how the survival rates is improving, or retention rate or churn is improving or getting worse or not. Okay. So that's that. I think that's pretty much the cohort analysis that I wanted to cover today. So the next seminar, I like to kind of like advance this topic into the customer lifetime value, how we can calculate the customer lifetime value. So for subscription business, it's important to know how much you can make as revenue from your customers, right? It's not like typical transactional business. Like you subscription business, you accumulate the revenue over time. Then like if you know like how much you can actually make out of it from your customers, then you can correctly or more accurately like calculate how much you can spend or how you can to acquire that customers, right? So then typically, hey, you know what, like we have like 12 months and each month customer pay $10. So like let's total is like $120. So that's something called customer lifetime value. Well, is that really $120? You can estimate that. And then based on $120, let's say, okay, let's spend $100 to acquire customers. Is that really the right procedure? Well, there's one problem, because not all customers become being the customers for the same number of periods. Like we saw the survival rate, right? So like even like when we have 100 customers, by the end of the first period, only 60 of them retain. So we can't really calculate by simply multiplying the number of the months or number of the years or so on. So first we want to get this survival curve, then or survival rates, more precisely. Then we use it to calculate the customer lifetime value, or CLV, and in that way it's more realistic numbers you can calculate. And then we can see like we just like we did for the cohort analysis, we can create, for example, Japan, United States, and different countries. We can draw the survival curves. Then we can calculate the CLV for Japan customers or United States customers, and so on. Okay, so how we do it, it's more to do with the data wrangling or the side of things, but that's the topic that I like to cover. And also probably if we have enough time, I'd like to do data wrangling for how to prepare the data for the survival curve. Today that's the topic we skipped. Okay, so that's it for today. And then with that, I'd like to open up Q&A session. If you have any question, please let me know. And there's a chat window. And then if you like to talk, you can unmute yourself. Either way.